We closed the previous podcast with a brief description of how a microprocessor is fabricated. In part 2, we will show you how a printed circuit board is designed and fabricated. The dimensions are different, however, this is similar with respect to the processes associated with manufacturing microelectronic components like microprocessors, microcontrollers, field programmable gate arrays, and other integrated circuits. Microprocessors depend on a printed circuit board to connect with a power source, external memory components, inputs and outputs, and the internet. The microprocessor I use to create these podcasts is much more complex than the 8-bit device featured in part 1 of this series. This 64-bit 12th generation multi-core processor has 1,700 pins in the LGA package that connects to the main printed circuit board. The socket clamps the processor to the mating pins, thermal interface compound is applied to the heatsink surface, and a cooler is attached to dissipate the heat generated by the billions of transistors which comprise the circuitry within the processor chip. Design begins by specifying exactly what functions the circuit will be expected to perform. In the case of microprocessor design, this includes the instruction set, which will be called upon by the application software to do useful work. The next step is to produce the gate-level schematic diagram that defines how the ALU, on-chip memory, registers, and other sections are wired together to form the complete processor. When dealing with a processor circuit with billions of transistors on a chip, computer-aided design tools are employed to reduce development time and effort. A printed circuit board design can be used as an example to illustrate the process. The circuit we are using as an example contains digital AND gates, OR gates, JK flip-flops, decade counters, discrete transistors, and various passive components. Referring to the completed wiring diagram, we can define the placement of components on the circuit board and route conductive paths to form the printed circuit pattern. This drawing, which is typically 4 times or 2 times scale, is overlaid with transparent film or a masking film. Pads and black drafting tape is applied to produce an oversized image of the board pattern, which is then reduced to an exact size negative film. A copper-clad board is coated with photosensitive etch resist, and the negative, which is also referred to as a photo tool, is contact printed to form the etch resist pattern, which is developed to expose areas of copper which will be dissolved by the etch solution. When the etching process is complete, the boards are cleaned to remove resist from the remaining copper traces. Holes are drilled to align with the component lead frame, and all parts are assembled on the board and soldered in place.